Let's talk about the primary differences between wireless LANs and local area networks. So one of the key differences here is that we're using RF frequency or radio waves to communicate at the physical layer, as opposed to transmission of ones and zeros over copper or fiber optic media. In this case, we're using RF to transmit the ones and zeros for our physical layer. Wireless LANs use something called CSMA-CA, which is Carrier Sense Multiple Access with Collision Avoidance, as opposed to Ethernet, which uses Carrier Sense Multiple Access with Collision Detection. This is a two-way radio communication, but it is half duplex in nature, and it's a shared media just like we had in a hub environment. So anybody listening, turning on a sniffer in a wireless environment, can hear all the data being sent by all the other wireless clients. So we have to be cognizant of the type of communication traversing the airwaves and make sure it's encrypted so that nobody can gain access to our intellectual property as we're sending it over the network. And I mentioned intellectual property, and it's kind of funny. We talk about IP all the time, and you're talking to a bunch of engineers, and it's IP this and IP that, and I've got this IP address and this IP problem and so on. If you have the same communication with lawyers, every single time you mention the word IP, they're thinking intellectual property, not Internet Protocol. So sometimes you have to be careful where you're using that acronym and the language you're expressing when using that acronym, depending on who you're talking to. But sorry about the tangent there. All right, so back to the differences between wireless and wired LANs. Other kinds of connectivity problems are going to be prevalent in a wireless environment that we've never experienced in any environment built with wires. Things like coverage problems or microwave ovens inside of our building, various types of interference that can occur. The fact that this is transmitted over unlicensed frequencies, to where in a multi-tenant environment you could have several people who want to deploy wireless, but because they're all trying to deploy wireless over the same unlicensed frequencies, they could be interfering with each other and nobody's able to communicate properly. And of course, there's the security issues as well, which is a completely different form of security because we're broadcasting this stuff over the air. Anybody in close proximity can certainly listen to the information that we're sending. Therefore, we have to make sure that all of our communication is encrypted. There's also various things we have to worry about from a standpoint of where we're deploying it. Every country or certain regions will have different regulations as far as what frequencies you can and cannot use in respect to wireless networking. I don't know if you've ever heard the definition of RF, but radio frequency and the transmission of radio frequency is essentially the result of radiated power pushed into an antenna of some kind, creating radio waves over an environment. Of course, we've all had, FM, AM radios or used cell phones and so on. All of this technology is essentially used over certain frequencies generated by the amount of power and the type of antenna we're using to generate these waves. Now, these waves have certain problems as far as overall propagation. So things that can create problems are reflection or scattering or absorption of these radio frequencies depending on what they're actually hitting. So if they hit water or a metal wall or a file cabinet or encounter some kind of additional radio frequency at the same transmission, we can end up with problems of the overall propagation of the radio frequency domain. So the higher frequencies we end up having also creates a higher rate of data that we can send over the radio frequency. But there's a corollary there. If we use a higher frequency, it has less of a range. So we have to push more power into it to get more range out of it if we have a higher frequency.